Hello, my name is John Paul, and today I will be showing you my project. This project tackles something called system integration, where subsystem A, or the data provider, provide data, and subsystem B displays or uses the information. So as you can see here in my project folder, I have two folders inside. One is labeled subsystem A, and the other is subsystem B. My project is to make them communicate using one of the three integration models: data integration, functional integration, and presentation integration. So now, what are these models? To sum it up, data integration directly ingests the data files or API-like responses, while functional integration invokes functions or procedures in subsystem A from subsystem B. And last is presentation integration, where it displays subsystem A's data via subsystem B's UI layer without modifying core logic. So now, this project is written in such a way where subsystem A outputs data into a CSV file, and subsystem B reads and parses that file to use the information. In other words, this project uses the data integration model. As we can see here in subsystem A, this is like the basis of the system where subsystem A can run on its own. But if subsystem A was missing, then subsystem B would not work. So here subsystem A provides the proper format, let's say, to the CSV file on the information that we will put. So as you can see here, we have the name, the age, and the the course. So then here we have the different variables. And if we set subsystem A as the main, here, uh, let's say we delete the files for this project. The files here. Let's say we delete this. So now, if there's no file yet in the directory, then it will make a new file. And this is done so that it mimics a API response. So it's a mock API response. And now let's try to clean build or just build. Now let's try to run. So as you can see, subsystem A has generated a students.txt file. So let's check it. Here you can see it. And as you can see, we have the information here. So now let's use subsystem B. So let's set subsystem B as the main. So let's okay, so let's clean the there. So now we have this new UI and some additional features that were not present in subsystem A. So let's say we want to add a student. So now we have added a new student and in the text file. So let's see if it reflects here. As you can see, it's not here. So you can also delete the student. So let's delete this first code right here. Let's type this in. So now he has been deleted. And then there's also something called statistics. So you can see the different statistics of that's inside the file. So there's 3 students, the average age, and um, the different courses. And this is a clear example of data integration where the two subsystems communicate through the shared data. So the shared data that's inside this text file, rather than something like direct function calls. So to justify the roles of both subsystems, we can instead view it this way. Subsystem A is the producer, generating and supplies data in a structured format, while subsystem B is the consumer. It ingests the data, allows user interaction, and persists changes back to the file. This separation mirrors some real-world systems where only one provides raw data and at least one other subsystem consumes and/or manages them. So now I should address something important in integrating systems: pain points. For example, data format mismatch, structural differences, or transformation requirements can break one of the subsystems or make it difficult to integrate. Pain points in system integrations are the common challenges or obstacles that organizations face when trying to make different subsystems, applications, or data sources to work together. In my project, Subsystem B relies on Subsystem A to write data in CSV format so that it can parse records correctly. Both Subsystem A and B have their own student class, which are similarly structured but are in different packages. So if one of the student structures were suddenly changed, the other subsystem won't know and can lead to mismatches. Subsystem B also does not have a way to know if a record is invalid. So if subsystem A writes incomplete or malformed data, subsystem B may crash or misinterpret the data. This project mirrors real-world integration scenarios where one system produces structured data and another consumes it and manages it. For example, school enrollment system often exports student records in CSV files that grading or attendance systems must import and process, just like subsystem A and subsystem B in my prototype. The reliance on a shared format highlights common integration challenges such as data consistency, transformation needs, and interoperability, which are also faced in industries like HR, finance, and healthcare. And that's it from my project. Thank you so much for watching. And thank you for listening to me presenting my project. That's all.